All right, let's take a look at the problem of finding and classifying local maximum, local minimum, and saddle points of x cubed plus y cubed minus 192x minus 12y plus 2. So first we are going to take the partial derivatives and set them equal 0. And we know that the critical points, for critical points, both of these partials must be equal to 0. In other words, gradient will be equal to 0. So for fx, you can see that that's just going to be 3x squared. Y cubed term will become 0. Then here we'll get negative 192, and the rest does not have an x, so that just becomes 0. For fy, we will get 3y squared similarly, and then minus 12. Now we set both of these equal 0. If we were to solve them from the first equation, it can be shown that x squared will just be 192 divided by 3, but that's 64. So you can see that here I went ahead and divided it, and that's 64. And then from the second equation, you will see that y squared equals 4. Now, whenever a number squared equals 64 or 4 or something like that, you have to remember that you actually have two different solutions. So it's not just x equals 8, but also x equals negative 8. And same thing over here will be plus minus 2. Now, any of these combinations of pluses and minuses will be a potential critical point. So let's see if we can fill this out. So this will become 3x squared minus 192, and then this will become 3y squared minus 12. All right, so solving that, we're going to get a whole bunch of critical points because x could be either plus or minus 8, and also y could be either plus or minus 2. So all possible combinations, one positive, one negative, or both positive or both negative. So that would be something like that. So those are your 4 critical points. Okay, so once you find them, you have to classify them. In order to classify them, so I'm going to separate the calculator. I'm going to put that here on the right side of my screen. And let me go ahead and define. So first of all, you should define the partial derivatives. So that would be 3x squared minus 192. Now, this sub x is the underscore. Underscore, to type underscore, you type F, then you press shift minus, that makes it an underscore, and then x. Okay, and then same thing here. So f sub y is going to be 3y squared minus 12. Now, to make sure that I got the critical points, which of course over here I see that I got that right, otherwise I wouldn't check it, but you are supposed to check for both fx and fy. For each of these critical points, the fx and the fy has to be 0. So you can change these and you will see that that's going to be 0. And then if I change this one, that's 0. And if I take away minus over here, that's also 0. So I know these are critical points. Be very careful. Don't proceed until you make sure that both fx and fy are zeros. Okay, so the next part is to compute xx derivative, which is take the derivative of this term with respect to x, and that'll give me 6x. And next, fxy derivative. So that will take this again and now take the derivative with respect to y. However, since none of the terms have y in them, that's just going to be 0. And finally, fyy, that will become 6y. Okay, so with that said, one other thing that you are supposed to do here is go ahead and define the d of xy. This is something that d stands for determinant, is something that you need to use a so-called second derivative test for local extrema and saddle point. So we got we take fxx, and I can just copy paste that here, multiply that by fyy, and then subtract fxy squared. Okay, so that's my d. Now I need to compute all these things for the points. So first let's start with a2. Okay, so I didn't define the function itself. So f of xy, let's go back and see if I can type that. Okay, so now it'll tell me, okay, oh my God, look at that huge number. Okay, whatever. Now I'm gonna also get the xy at this point, so that's 48. And I'm also going to get D at this point. So that's 576. Now, to classify that, the second derivative test is this. If D is positive, look at the sign of fxx. If it is positive, it's a minimum. So it's like the opposite. Okay, so this is a minimum. Okay, so now for negative 8, 2, let's change all of these to negative 8 and then fill this out. These are some sure really large values here. Now, when D is negative, actually that's easy. You do not even have to look at fxx. If it's negative, it's a saddle point. So we've got that. Okay, now let's look at negative 8, negative 2. So let's see if we can fill that out. Okay, here I see that D is positive. So this is where I do have to look at fxx because it's negative. It's kind of like the opposite. That would be a maximum. Finally, 8, negative 2. So let's change that and fill this out. Okay, so this is 48. And then that's negative 576. So looks to me like that's another saddle point because D is negative. So that's a saddle point. Let's check that.